Hi, boys and girls. Today you're going to be doing lesson 7-3, which is adding fractions with unlike denominators and adding mixed numbers with unlike denominators. So I'm going to start with my first example, which is 2/3 half. Okay, and if I go to add 2/3 plus a half, the first thing I notice is that they both have unlike denominators or different bottom numbers. And that can make it a little challenging to add them together because you're basically adding something that's cut into thirds or 3 parts with something that's cut into halves or 2 parts. So if I can find a number that 3 and 2 share in common, or a fractional part that they share in common, then it would be a lot easier to add them. So the way I could do that is by making a multiples list. So I'm going to go down here. And making a multiples list is when I just count by these two numbers and write down the answers to my multiplication facts for them. So when I count by 2s and 3s, 2 times 1 is 2, and 3 times 1 is 3. And I want to see where I get a match between these two numbers, where I get a number that they share in common as an answer, or a multiple that they share in common. So 2 times 1 is 2, 3 times 1 is 3, 2 times 2 is 4. I still have no match. 3 times 2 is 6. Let me try it again. 2 times 3 is 6. And 3 times 3 is 9. But if I look, I had a match with the number 6. So this is the least common multiple, or the smallest number that 2 and 3 share in common when you're counting by 2s and 3s. So I'm going to use that number. And I'm going to make equivalent fractions to 2/3 and a half, but I'm going to make them be equal in fractional parts of 6. So I have to make equivalent fractions, but I have to figure out, well, what is a half in 6? So the way I'm going to do that is going to go back to my list. I'm going to put where I multiplied, and I'm going to put multiplication symbol here, and here, and here, and here. And then I'm just going to run through my fact. So 2 times what gave me 6? 3. Well, I'm making equivalent fractions. So whatever I do on the bottom, I have to do on the top. So I multiplied by 3. 2 times 3 is 6. So then 1 times 3 would give me 3. So a half in 6 is equal to 3/6. Similarly, I'm going to do the same thing for thirds. So 3 times what gives me 6? 2. Whatever I do on the bottom, I do on the top. So 2 times 2 is 4. Now you can see that both of these original fractions are in sixths now. Okay, so now they have like denominators, so I can easily add them. And remember, when I add fractions with like denominators, I just keep the denominator. Okay, so my denominator is 6, but I'm going to add my numerators. 4 plus 3 is 7. Okay, well, this is adding a little extra challenge here because this is an improper fraction, and we know we're not allowed to keep that. So I'm going to have to divide it out. I'm going to have to do the inverse of multiplication, which is division, to get rid of this improper fraction. So I'm going to divide 6 into 7. When I count by 6s, 6 goes into 7 once. Multiply back. 1 times 6 is 6. I subtract. I get a 1, and I'm bringing it up, and I'm putting it over my denominator, which is 6. So my final answer here is going to be 1 and 1/6. Okay, let's try another one. Now I'm going to put another one up here that's a little bit more challenging because you might end up seeing on some of your work or in today's lesson that you might have 3 fractions to add together. And you're just going to follow the same rules in order to solve. Move my plus sign down here. So again, I want to add something that's cut into fourths with something that's cut into thirds with something that's cut into sixths. And that's a little bit challenging, but not as hard if I get them all to have the same denominator, because right now they have all different bottom numbers or denominators. So I'm going to have to make a multiples list for 3, 4, and 6. And again, if I run through my multiples or my answers to my multiplication facts for these numbers, 3 times 1 is 3, 4 times 1 is 4, 6 times 1 is 6. 3 times 2 is 6, 4 times 2 is 8, and 6 times 2 is 12. So again, I still have no match. 3 times 3 is 9, 4 times 3 is 12, and I have 6 times 3 is 18. But if I peek back, sorry, I still don't have a match. So I'm going to go back to threes. 3 times 4 is 12. Oops, it's 12, sorry. So when I peek back, the least common multiple that all three of these numbers, 3, 4, and 6, have in common is the number 12, okay? So I'm going to make that be my new denominator for these fractions. I'm going to put in my multiplication sign because I was making multiples to find 12. 12 is the least common multiple. And I'm going to run through my times table facts. So 6 times what gives me 12? 2. I'm making equivalent fractions. I have to figure out what is 1/6 equal to in twelfths. So 6 times 2 is 12. Whatever I do on the bottom, I got to do on the top. 1 times 2 is 2. 3 times 4 is 12. Whatever I do on the bottom, I'm doing on the top. So 1 times 4 is 4. And lastly, 4 times what gives me 12? 3. Whatever I do on the bottom, I'm going to do on the top. So 1 times 3 is 3. So now they're all in twelfths, and I can add them. I'm going to keep the denominator of 12. Now I'm going to just add my numerators. 3 and 4 is 7, plus 2 is 9. So this one was nice because it wasn't an improper fraction, but it still got a little bit of an added challenge in that this is not in lowest terms. So now I have to switch back to GCF, where I have to think of what is the biggest number that you count by, and I could hit these multiples of 9 and 12. Well, and I'm going to divide by that number. So the biggest number that I can think of that I count by and I hit 9 and 12 is the number 3. Okay? And if I run through my division fact here, 9 divided by 3 is 3, and 12 divided by 3 is 4. So this is in lowest terms. Okay, this is fully reduced. This is fully simplified. And I'll know that because usually you're in lowest terms if either your numerator is 1 or if one of these numbers is prime. And in this case, 3 is prime. The only way I can get 3 is by multiplying 1 times 3. Okay, so that's 2 examples that we're doing with adding fractions. Now I'm going to try a couple examples with adding mixed numbers. Again, you're going to follow the same rules. Only one little difference is that if you notice, instead of just having fractions here, I have some whole numbers, okay? But I like thinking of it this way, that I sometimes like putting a line here and separating them and having them stay in their own lane, okay? So I'm first going to do my fractions and add them, and then I'm going to add my whole numbers, okay? So again, I have to make a little multiples list, because again, I have unlike denominators here. So I'm going to count by 8s and 12s. I count by 8. 8 times 1 is 8. 12 times 1 is 12. And again, why am I doing this? Because I can't add fractions with unlike denominators. I have to find the least common multiple, or a number that they share in common, that I can make as my fractional part, new fractional part or equivalent fractional part, and then add them together. So 8 times 1 is 8. 12 times 1 is 12. No match. I'm looking for a match in both rows here. 8 times 2 is 16. 12 times 2 is 24. I still don't have a match. But when I go back to 8s, 8 times 3 is 24. Okay? And I don't really need to keep going with 12 because I already have the match here. So the least common multiple, or the smallest number that 8 and 12 share in common when I'm counting by 8s and 12s, is 24. So I'm going to put this as my new denominator. But again, I've got to figure out, well, what is 8s? What is 3/8 in 24ths? So again, I got these answers by multiplying. So I'm going to put the times symbol. I'm going to run through my facts. 8 times what gives me 24? 3. Whatever I do on the bottom, I'm doing on the top because I'm creating equivalent fractions. So 3 times 3 is 9. 12 times what is 24? And Lon says you could just peek back at your list here and you'll get your answer. 12 times 2 was 24. Whatever I do on the bottom, I'm going to do on the top. So 7 times 2 is 14. Okay, so now I can add them because they're both fractions they have the same common denominator. They're in 24ths. So I'm going to bring down my 24, because remember, when we add fractions with like denominators, we keep the same denominator and just add the numerators. And when I add 14 and 9, I'm getting 23. Now, I don't have to further reduce this because 23 is prime. Okay? And then when I go and I add my whole numbers, 2 plus 1 is 3. So my final answer here, they're a little bit separated, so I'll put them together, would be 3 and 23/24. And again, this is in lowest terms because it's prime, and also I don't have an improper fraction here, so I don't have to divide. Let's try another one. Let's see. Let's try 3 and 8/9 plus 8 and 1/6. So again, I'm looking to add a mixed number to a mixed number. I'm going to kind of separate them, have them stay in their own lane. I'll add the fractions first, then add my whole numbers. So when I count by nines, when I think about it and I count by 9s and 6s, I have to think, what number do they share in common? So again, I'm going to make a multiples list. I've got a 6 here and a 9. Okay, when I count by 6s, 6 times 1 is 6, 9 times 1 is 9. I have no match. 6 times 2 is 12, 9 times 2 is 18. I still have no match. But when I go to my number fact of 6 times 3, I get 18. I really don't have to keep going because I found my match. So that's going to become my new denominator. Okay, but I'm going to have to figure out what is a 6th in 18ths. So I found this denominator by multiplying, so I'm going to put in the times symbol and run through my number facts. 6 times what gives me 18? 1, 2, 3. Whatever I do on the bottom, I do on the top. So 1 times 3 is 3. 9 times what gave me 18? 9 times 1, 2. Whatever I need to do on the bottom, I'm going to do on the top. So 8 times 2 is 16. I have the same denominators here. So when I'm adding fractions with like denominators, I just bring down my denominator. But I have to add the numerators. 16 and 3 is 19. So now this is one where we're stuck with, and we have an improper fraction. We can't leave it. I'm going to get rid of this little multiples list here because we've already used it. How am I going to get rid of this? I'm going to divide. So 18 goes into 19. 18 can't go into 1, but 18 can go into 19 once, okay? Because 2 times 18 would give me 36. So 1 times 18 is 18. Subtract, I get a 1. I bring it up, and I put it over the number 18. So I'm ending up with, when I add 8/9 and 1/6, I'm ending up with a mixed number, 1 and 1/18. But I can't forget I have to add my whole numbers here. So when I do 8 and 3, I get 11. And then what I'm going to do is I'm going to bring this mixed number over here and just add it on. And again, I'm keeping my fractions and my whole numbers separate. So 1/18 and nothing is 1/18, and 11 plus 1 is 12. So my final answer here would be 12 and 1/18. And again, this is in lowest terms. You'll know it because I have a 1 here. I can't get any lower than that. I'm going to do one more example with you. Okay, I'm going to do 2 and 3/4 plus 7 and 3/5. Again, I'm adding a mixed number with a mixed number. They have unlike denominators. Okay, so I'm going to have to think, when I count by 4s and 5s, what's the smallest answer, multiplication fact answer that they share in common, or the smallest multiple, least multiple that they share in common. So I'm going to count by 4s and 5s. Okay, so making a multiples list here. So when I count by 4s, 4 times 1 is 4, 5 times 1 is 5, no match. 4 times 2 is 8, 5 times 2 is 10, still no match. 4 times 3 is 12, 5 times 3 is 15, still have no match. 4 times 4 is 16, 5 times 4 is 20, still no match. 4 times 5 is 20. Well, look at that. I got a match. Okay, so that's going to be my least common. That's the least common multiple that 4s and 5s share in common. So that's going to become my least common denominator, my new denominator for these two fractions, 3/4 and 3/5. So I'm going to make this be 20ths. And again, I just basically, by putting that, I'm making equivalent fractions to 3/4 and 3/5. I'm going to put in a multiplication sign on the top and bottom of each of these fractions, because that's how I found this multiple, was by multiplying. And I have to think, what is 3/5 in 20ths? So 5 times what gives me 20? Okay, 1, 2, 3, 4. Whatever I do on the bottom, I'm doing on the top. So 3 times 4 is 12. 4 times what gave me 20? 1, 2, 3, 4. 4 times 5. Whatever I do on the bottom, I'm doing on the top. So 3 times 5 is 15. Now I'm basically adding two fractions, 15/20ths and 12/20ths, that have like denominators. Nice and simple. When they have like denominators, I'm just keeping the denominator, 20ths, but I'm just going to add the numerators. 15 and 12, if I do it over here, just to show you, 15 and 12, 5 and 2 is 7, 1 and 1 is 2. So I've got 27/20ths, okay? Only problem with this is an improper fraction. And remember, I'm going to have to basically make this into a mixed number, and then I'm still going to have to add my whole numbers and add it on. So let's divide this out. And I'll get rid of this, so I got a little bit more room. 20 goes into 27. 20 can't go into 2, but 20 can go into 27 once. 1 times 20 is 20. Subtract, I get a 7. Okay, 20 can't go into 7, so I bring it up, and I put it over what I was dividing by, which is 20. So my answer for 3 4/5 and 3/5 is 1 and 7/20. Okay, but I still have to add my whole numbers here. So 7 and 2 is 9, and then I'm going to bring this over and add on the 1 and 7/20. Again, if I have them stay in their own lane, 7/20 and nothing is 7/20, and 9 and 1 is 10. So my final answer is 10 and 7/20. Okay, I hope this helps, and good luck with your questions today, and I will see you soon. Bye.